Hi, so the topic for discussion is the array of products, and it's an interview question here. So given an array like this, so that's the elements are 5, 1, 4 and 2, the output should be the output of all the elements in the array except the element I am currently at, right? And I hope that will make you understand. Let's see. So when I'm at element 5, the output should be the product of rest of the elements except 5. So that's 1 into 4 into 2, which will be 8. When I'm at 1, the product should be, in fact, the answer should be at the position where 1 is. The answer should be the elements products except 1. So that's 5 into 4 into 2. 5 into 4 is 20. 20 into 2 is 40. So this should be 40. When I'm at 4, the answer should be 5 into 1 into 2. So it's 5 into 1 into 2 and not 4. I'm not including that 4. So that's 5 into 1 is 5. 5 into 2 is 10. So that's 10. When I'm at 2, I'm including all of these. So 5 into 4 into 1. So that's 20, excluding 2. And I hope that makes sense. So this is basically the product of array except the current element, right? It's as simple as that. Well, the implementation part cannot be as simple as that. It might be for you if you have gone through this problem earlier, but if you are seeing this for the first time, there's a little implementation part which you have to take care of. Let's see. So the naive approach here should be to traverse the array once. Just traverse the array once to compute a variable. For example, if I store a variable called multiply, so my multiplication variable at the end of the array, so what I'm going to do is traverse each and every element of the array and compute the array product. So that's 5 into 1 into 4 into 2. So that's nothing but 5 into 1, 5. 5 into 4 is 20. 20 into 2 is 40. So my multiplication variable will hold the value 40. And my answer will be as simple as what the statement says. My statement says here, product of array except the current element. So maybe my output should look like this. Output should be basically 40, which is nothing but the multiplication symbol, by 5, should be 40 by 1, should be 40 by 4, and this should be 40 by 2. Notice that 5, 1, 4 and 2 are nothing but the array elements. So I am computing the entire product except the current element, which is 5. Maybe like consider this one, right? Why I'm dividing it by 4? Because I'm not including the number 4, right? Excluding it. It's saying that except the current element. So I just divide it by 4. And output will be as simple as, simplify this. So this should be 40 by 5 is 8. 40 by 1 is 40. 40 by 4 is 10. And 40 by 2 is 20. And you can kind of match this output with this output and it comes out to be true, right? Now, what is the time complexity for this? Well, the time complexity for this, I'm just going to write it up here as well. So we are traversing the array once, right? We are traversing the array once to compute the multiplication variable, right? Which is nothing but this one. So that's big O of, I'm just going to write it as n. And then we are traversing the array once more just to update the array elements. So how do we update that? We just traverse it and divide it by, divide 40 or the multiplication value by the current array elements. And that's how we get the answer. So that's n plus n, which is 2n. And this can be simplified as big O of n. What is the space complexity? Space complexity is big O of 1, right? Now, this looks like quite an efficient solution. And that is an efficient solution. In fact, it is an efficient solution. But in the interview, what if the interviewer says that you don't have to use the division symbol, right? You don't have to be using the division symbol. And definitely he won't say that you might not use multiplication symbol. So you are only allowed to use multiplication symbol. Only multiplication is allowed. In fact, I'll just write it completely here. So multiplication is allowed. And how do we do that? Well, we kind of make use of concept of prefix array and suffix array. What does prefix array means? So my prefix array is going to be storing some valuable information from the pre part of the array. So if this is an array, for any element, this is the pre part and this is the post part, right? This is the pre part and this is the post part. You can kind of make sense, right? So we are going to be computing prefix and then the suffix array. let's see how we are going to do that. Notice attention, pay attention closely, right? So that's 5, 1, 4 and 2, which is nothing but the original array. How do we compute prefix and suffix? Well, for prefix, I'll maintain a left running product, right? So left to right, I'm going to go from left to right for prefix. Let's see. So I'm going to maintain a product like left to right running product, right? So initialized by 1, and just for safe measures, I'm just going to write it in small. So LTR, left to right, and it's initialized to 1. So at the beginning, right, this is the prefix array. It's going to be of the length same as the original array, right? So that's 1, 2, 3, 4. The indices are written below. That is not a problem. And at the beginning, right, so at the beginning, I'm going to be storing at the current element. In fact, at the current element, I'm going to be storing the product of all the elements coming before that element, right? So before 5, what is coming? There's only nothing, right? So I'm going to be writing 1. Now, before 1, what is coming? That's 5, right? But how do I compute that? I just computed with the help of LTR. At this point, I'm going to be writing LTR is equal to LTR multiplied by the element at the ith index in the original array. Now my LTR will be 5. Left to right running product will be 5. And at this point, what is the product of all the array elements to the left of it? That's 5. And this will similarly go on. This formula will kind of recursively go on in the for loop or the while loop, as the case may be, and compute it. So at 4, what will be the product of all the elements to the left of it? That's 5 into 1, 5. Again, it will be 5. At 2, what will be the product of all the elements to the left of it, right? Well, it's 5 into 1 into 4. That's nothing but 20, right? So the prefix array comes out to be 1, 5, 5 and 20, right? Now let's just compute the suffix array. Suffix array is kind of similar, but it begins from the end of the array. So my array elements are 5, 1, 4 and 2. My suffix array should be the same as the original array's length, and we're going to be starting from here. Again, we can store a variable like maybe left to right, right? So in this case, it was left to right. In this case, it should be right to left, and it is initialized by 1. Again, the same formula will be applied here. The same formula as per the left to right. So my right to left formula should be right to left is going to be updated as right to left multiplied by array of I. And you can kind of figure this out when you dry run a code, right? I'm just explaining the concept here. So understand that at any position, I'm going to be storing the product of the elements to the right of it. So when I'm at 2, is there any element to the right of it? Well, there is no element. So up here, the answer should be 1 in the suffix array. At 4, I will have the product of every element to the right of it. So that's 2. At 1, I'll have product of every element to the right of it. So that's 4 into 2, 8. At 5, I will have product of every element to the right of it. So that's 4 into 2, 8. 8 into 1 is 8. So I have 8, 8, 2 and 1. It's as simple as that, right? Now, what will be my answer here? Well, I have not even used a division symbol here. So I am kind of following what the interviewer has said. Now you can interestingly see that my answer should be, at any position, my answer should be the product of the suffix and the prefix array at that ith position, right? Maybe just write 1, 5, 5, 20, 8, 8, 2 and 1. I'll just write it up here. So my suffix array comes out to be 8, 8, 2 and 1. As simple as that. So my original array will be updated as the product of the corresponding index. So 1 into 8 is 8, 8 into 5 is 40, 2 into 5 is 10 and 1 into 20 is 20. So my answer is 8, 40, 10 and 20, and that's how the original array gets updated. 8, 40, 10 and 20. Now you can notice that when I was explaining the naive approach, right, the answer was same as before, but 8, 40, 10 and 20. But you can notice here that we have not even used the division symbol. We have only used the multiplication symbol, and that kind of follows what the interviewer asks, right? Even in this case, we were multiplying, right? And when we were computing the prefix or the suffix array, we were even using the multiplication symbol, right? Now, let's see how this can be implemented. I'll use some example which I tried to make you understand from. So this should be, I'll just write some code here. I think I should have written it earlier. That's not an issue. So this should be 5, 1, 4, 2, just using the example. And my new array will be array of products. This is my function which is going to return me the new array, and I'm just going to pass array as the parameter, right? And at the end, I'm going to print new array. I'm left with defining a user-defined function. So define array of products, right? And then my array argument is passed, right? So this is something which even you are trying to explain to the excuse me, interviewer, you have to just say that when I'm passing here, this is a parameter, right? Because I'm kind of passing it at the time of function call. But up here, when I'm writing array, this is known as an argument. I hope I have not mixed up those two terms. So if I have mixed up, you can kind of correct me, right? So up here, we call this as parameter, and up here we call this as an argument, right? So I think that makes sense. And let's just write some comments, or maybe like the procedure we are going to follow. So at first, maybe compute the length of the array, as simple as that. Then we can compute, I think I messed up the spelling. So compute the prefix array, right? And then maybe compute the suffix array, and then maybe update the original array with values prefix of I multiplied by suffix of I. That's what we saw there, right? And then at the end, return the modified array, right? Or return the modified array. Okay, I think my video is on here. Okay, so return the modified array. Now let's just do it. So compute the length of the array. So n is going to be length of the array, as simple as that. Compute the prefix array. Well, how do I do that? So I'm just going to define the prefix array and initialize it with 1. And what will be the length of this? The length should be n. N is nothing but the length of the original array. Now I'll maintain one variable. This is going to store the running product from left to right. So left to right running product initialized to 1. So for I in range n, I'm just going to loop through it, and at the first index, right? Well, at the first index itself, my basically, so I'm just going to write if I is equal to 0, or maybe I can just write temp value. Okay, wait, I think I should make it as simpler for you guys to understand. So up here, you can see that prefix array is initialized with 1 into n. I mean, this means that this is going to be internally looking like this. So 1, 1, 1, 1. This is the length of the array, right? Now, left to right running product is initialized with 1. So how do I update the prefix array? Firstly, I have to update the prefix array with the left to right running product. So my prefix array at ith position should be left to right running product, and then I can kind of update the left to right running product as left to right running product multiplied by the element at the ith position. As simple as that. Let's see if we are on the same page. I think I might have made a mistake, but let's see. So just going to write, maybe I think I have read this. Yeah. So Python array products.py, and it's 1, 5, 5, and 20. I hope that kind of resonates with what I have written here. So yeah, that's it, right? So this is what we get, 1, 5, 5, 20, right? And maybe we can compute an arbitrary example here. So maybe 11, 1, not just use 11 here, makes the number system complex. So 3, 5, maybe 4, and then 2. We'll just check with this random example, right, later on. So I think we are on the right page. So prefix array is correctly computed. Now, how do I compute the suffix array? The first step is to initialize it. So suffix array is going to be initialized with 1 multiplied by the length of the array. So this is again a bunch of ones, right? So again, this is a bunch of ones. How many times? 4 times, right? Now I'm going to be having a right to left running product, right? So it's going to be right to left running product. So right to left running product, because I'm going from the right hand part of the array to the left hand part, right? So I'm going to be looping through the array, but from the back. So n minus 1, I'm going to be going till 0, so that's minus 1, and a step up value or a step down value of minus 1, right? Now, how do I do this? Again, the formula will be quite simple and as same as the prefix array. So it's going to be suffix array of I, or at the ith index, should be initially right to left running product, and then right to left running product should be equal to right to left running product multiplied by the element in the original array. That's very important, right? Now that we have done this, well, I think we should just check with this. So print suffix array and check if we are on the right page, and it comes out to be 8821. Let's see. So my suffix product was coming out to be 8821, and think we are on the right page. Okay, that's perfect. So now that we have done this, it's saying that update the original array with values prefix I into suffix I. Well, we can easily do that. So I'm just going to loop again through the array, right? We are going to be looping again through the array and simply update the array ith element, right? Or the element in the original array at the ith index as prefix array of I multiplied by suffix array of I, right? And it's saying that return the modified array. I think I'm qualified enough to do that. So return the original array, as simple as that. And when the original array gets returned, it gets kind of stored or initialized to this new array, and then I'm printing the new array here, right? Let's see. So I'm just saving this quickly, and python array products.py 8, 40, 10 and 20, and I think that was something which we were getting by the example as well, right? Or the dry run. So 8, 40, 10 and 20. Notice that as the interviewer said that we have to not make use of the division symbol, I have not made use of it. You can even see that, right? We have just only made of the multiplication symbol, and we were able to compute the answer. So I think I just wrote some random example here. Yeah, 3, 5, 4 and 2. What will be the output here? Just quickly write that. So my output should be, you can even write it on your paper or a piece of A4 size paper. So for 3, this should be 5 into 4 into 2. I think 5 into 4, 20. 22 is a 40. For 5, excluding 5, so 3 into 4, 12. 12 2 is a 24. For 4, excluding 4, so 3 into 5, 15. 15 into 2 is 30. And excluding 2, so that should be 3 into 5 into 4. I guess 5 into 3, 5 into 4, 20. 20 into 3, 60. I think answer should be 40, 24. Let's just see. 3, 5, 4 and 2. I hope I get wrong here so that I can kind of learn something from this. So 3, 5, 4 and 2. 3, 5, 4 and 2. And just save it here. So I'll just check what the answer comes out to be. 40, 24, 30 and 60. And I think that's something which we are even getting. So I hope you understood the video and the explanation. And if you have any doubt, you can kind of reach me, you can kind of write it in the comments, or maybe reach me on LinkedIn. I think it might be provided there, or you can kind of search me on LinkedIn, and you can drop me a message whenever I get free. Then I will be able to respond to your queries. So I think we will be able to meet in the next video. Thank you.